Thanks, Wayne. So yeah, we just had two short topics that we wanted to touch base on today due to some recent changes or forthcoming changes actually with regarding two services. So the first one is code signing. We've been having some performance issues recently, so we wanted to deep dive a little bit more about what this service is about if you don't know, and what is the plan to resolve the issues. And the second one is around the self-service, the GitHub self-service, and what it does, and what we'll do in the next couple of weeks. So let me share. Will it work like that? No, crap. Sorry. I should share this instead. Yeah. Please let me know if you don't see my screen, but I think I shared the proper content. So the first thing about the coin signing service and the performance issues that we've been having. So first of all, what's the fuzz with the code signing service? So code signing in this the meaning of code signing in those services, it's all about the platform and platform or operating system specific digital signatures that we offer to project, a service that we offer to project, so that their binaries can be verified, the publisher identity can be verified, and also the integrity of the binaries. So that's what provides Eclipse, what lets Eclipse project creates binaries for Windows that won't have those warning for UAC or the yellow or red warning with the user account control that says that the binary is unknown or from unknown origin. To do that, to provide this service, what the Eclipse Foundation does is that we acquire a certificate for code signing specifically, and for Windows, for instance, to pass the user access control, the UAC, it needs to be what is called an extended validation code signing certificate. Extended validation means that the certificate is issued to the Eclipse Foundation organization, but the certificate authority, in this case DigiCert, does a lot of background checks to verify that we are who we say we are. So we have to provide a lot of information. We have phone calls and so on to get this code signing certificate. So it's a lot of manual process behind the scene to get this properly from DigiCert. And what we provide in terms of code signing service is basically split into three parts. One for Windows with what Microsoft called Authenticode for portable executable, so the .exe or .dll. The jar signing service, so to sign your jars. Again, it's the same certificate as for Windows that is used. The JVM build, the Java distribution, all include the same kind of cert file as the one that Windows used to verify the binaries. And finally, the macOS code signing and notarization service. But this service uses a different kind of certificate that are issued only by Apple. So we don't buy it from DigiCert or any other certificate authority. So the recent changes and the changes, what led to the performance issue that we had is that for a year now, any new certificate issued by a code signing certificate authority has to be done, or the new certificates has to be issued on hardware security module. So that's new security measure for certificate authority, so that the EV certificates are recognized by operating system and platforms. Hardware security modules, if you don't know what it is, it's basically a USB stick that you need to plug into your machine, and that will be the secret manager for the private key that is used to sign, and you cannot extract the private key from those dongle, those sticks, but we'll also do a number of cryptographic functions, so the SHA calculation and so on, directly on the hardware. So we had to change the code signing services to actually use those the hardware security module rather than just files where the certificates were stored before. And the thing is, by having to rely on an hardware, something that cannot be replicated at will, just like files, led to the recent performance issues because, of course, because we have only one such modules, security modules, so we can only do one signing at a time and rather slowly because the performance of the stick that we have in terms of cryptographic functions is rather low. So we've made a number of attempts to solve the issue, and the very first one is that given that we have our own service for a long time, but it's a maintenance burden, so why not taking this as an opportunity to look at existing services, signing service that could be provided by an external third party. So basically all the code signing certificate authority offers similar service. So the SSL.com eSigner or the DigiCert Trusted Software Manager, they are all awfully expensive. We sign at the Eclipse Foundation between 10 and 15 million binaries per year with those certificates. And the basic or the low tier of usage from those services is in the thousands. So you can imagine that the scale is really humongous on our side, and we just cannot do that. We just cannot move to a digital signature as a service. So next up, as the main issue to the performance is the scalability of hardware modules, and that there exists cloud HSM, so cloud-based or cloud-hosted hardware security modules. So all the major cloud providers provide such a hardware security module on the cloud. Our goal has been to verify that we can actually use those hardware security module provided by cloud and check the scalability, basically, so that we don't have to manage the multiple connection to actual USB stick. Otherwise, we would have to deploy multiple USB stick on multiple machines or multiple VMs and do pass-through for the USB devices in VMs and so on. So that would be a maintenance nightmare. So that's really why we favored the cloud HSM attempt or investigation first before actually diving into the hardware side of things. So we successfully deployed a version of the service that use cloud HSM based on Google KMS. And it's currently working in the staging environment. So if you sign something with the staging endpoint of the signing services, you will use this. So we still have some scalability tests to be performed, but so far we are pretty happy with it. And the next step is to actually order and provision a new certificate, EV certificate, to be deployed on the cloud HSM, and so that we can restore the performance of the production environment. So the key takeaways is that the good performance that we were having before will be restored soon. But at the same time, we have all to realize as a community that we do too many signatures. If we reflect back at what is signed in those 10 to 15 millions, is that everything is signed. The CI, all the CI build, the nightlies and so on are being signed with a real certificate from the Eclipse Foundation. It means that any artifact that comes out of a CI is trusted by operating system platforms. So when the CI build come from sources that have been verified by committers, that should be okay, even though we could argue about that. But for PR coming from non-committers that are automatically triggered and signed with those official certificates, it could lead to very bad vulnerabilities. So someone could craft a PR to inject vulnerabilities and then distribute his code signed by the Eclipse Foundation. So we sign too many files, and we need to check on all those CI to remove the automatic CI signing code signing of at least the PR from non-committers. So we have some plan for 2025 to also provide alternative endpoints or parameter to make it easier for your projects to sign only releases, but still sign your CI/CD or nightlies build, so that you always have the same kind of pipeline. You don't sign only at release, which can be cumbersome because then you don't retest the signing phase of your build. But you may want to use, for instance, a self-signed certificates for your CI build and only use the official one, the real one for the releases. If you want to help with all of this, the code is open source, of course. It's hosted by the Eclipse CBI project. So feel free to go there, and we have tickets. We track the working tickets and PR, so you can have a look. Any question on that specific topic? No raised hand. Okay. So next topic that we wanted to discuss about is the deployment of the GitHub self-service, GitHub configuration self-service for all Eclipse projects. So if you don't know what's the GitHub self-service, I will describe it briefly, and then we will talk about the deployment that we will do in the coming weeks. So self-service is a way for projects to configure their GitHub organization and repositories. How does it manifest? The first thing that you would see for an organization with the self-service activated is a specific repo named .eclipsefdn for .eclipse Foundation, where we store the configuration files. Within this repository, there is a configuration files in the JSON format. It's a superset of JSON, basically, that gives you the opportunity to configure all aspects of your organization and of your repositories. So this is an example of such a file coming from FactorSex. But the self-service is not only about storing the configuration in a file, it's also a way for projects to make some changes to their configuration. So for instance, to enable branch protection or to change some other configuration on their repositories by creating PR against this configuration file. But it's not only the ability to create PR, it's also some verification service that will validate the configuration of those files and also provide you with some commands so that you can verify and apply the changes directly to your repository, depending on the permissions that you have on the repository. So only committers, for instance, or only project lead could merge, apply those services. So for instance, in this case, the project lead there asked for a merge of the changes, and then the tool named OtterDog actually apply the change directly to the GitHub organization, and it happened without having to open any help desk ticket or any support ticket with the foundation. It all happened within the project. So the GitHub self-service is a way for you project to manage and see the configuration of your GitHub organization and repositories. But all those information, we also fetch them, and it gives us the ability to create this dashboard to give us a global overview of the current state of the configuration of GitHub repositories. So of course, so for now, this dashboard is very oriented towards security settings, security features from GitHub. For instance, how many organizations and repositories have secret scanning enabled, or how many have two-factor authentication enabled, enforced. So of course, now since May, it's 100%, but before that, it was not 100. But a number that is interesting is the number of projects or repositories that have their default branch being protected, so preventing force push by default. Only 44% of the repositories are enabled. So for us, security team, it gives us the ability to see very quickly what's the current status and where we should put some effort and how we could help our projects. But you may see that in the dashboard, we have 109 GitHub organizations today that have this tool deployed on their organization. And what the plan in the coming weeks is to actually deploy this tool to all GitHub organizations managed by the Eclipse Foundation. So it's about 200 or a bit less than 200 organizations. So you already did that on request for about 100, half, and we are not enforcing the deployment, and we will now push for a more large-scale deployment of Eclipse OtterDog. We will keep you posted, of course, if you are part of a project that does not have this tool deployed yet. We will keep you posted. There are tickets opened where you can track the global effort, but also individual tickets or individual communication that will be issued to the project to let them know when it will happen. But it will have no impact on you if you don't want to use it and so on. You can continue as before. But otherwise, that will be a way for you to get a hand on the configuration of your repositories, things that you didn't have before. So the plan is as is. So starting the July 15th, we will enable it for all GitHub organizations that don't have it yet. At the same time, we also start to migrate project hosted on the Eclipse shared organization. So many projects have many repositories, one or many repositories under the Eclipse shared organization. We want to move them to a single one organization per project, so that it's better for security for many reasons. We have the ABS ticket to defining or explaining all the good reasons why it should be done for better isolation and so on. There is absolutely no downside to it because GitHub creates redirects for repositories, so it's really transparent for you or for your users. You will see everything will be redirected forever to your new URL or your new organization. And finally, the migration of projects that are still on Gerrit are also happening, moving either to GitLab and then eligible for the self-service OtterDog, or to GitLab if they want. And the same, likewise, exactly like for the split of the Eclipse shared organization, there will be communication with the project every single time to let them know and to let them choose whether they want to go to GitHub or GitLab. So if you need some help, once it will be enabled, you can go to your .eclipse FDN repository in your GitHub organization, and you can see all the configuration there. We also publish documentation on the second link, so you have all the documentation for the settings and what you can configure in your GitHub in the configuration file. There is the URL for the dashboard, so it's public for anyone to see. And you can always create an issue or a PR in your Eclipse FDN repository and tag the security team for help in those configurations. And of course, if you don't remember any of these, you will remember about the help desk, and you can always reach out to us over there. Any question about the self-service and Eclipse OtterDog? So there is one from Dennis on the chat. So what about GitLab? Will there be an OtterDog for GitLab as well? Yes, that's in the plan. We want to start work on supporting GitLab in OtterDog. The schedule or the timeline is not definitive on that. Hopefully, we'll have a POC by the end of the year in Q4, but otherwise it will slip in sometime in 2025. But that's definitely a goal as well. Yeah. Any other question?